Let's begin with a word of prayer. Dear Lord, we thank you for today, and we do thank you for your blessings. We ask that you be with us, help us to have a good Bible study together despite the rough start, help everything to work technologically, and help me as I speak to be able to communicate clearly and help everyone who's here to get something beneficial from this time. In Jesus' name, amen. Okay. Good evening, Stevie. Good evening, Albertsons. Good evening, Lorraine. And good to have each of you here tonight. Thank you for coming back. If you've joined our video, recorded video, thank you also for joining. Most of these are on YouTube. I did get a bunch of stuff uploaded to YouTube last week. I think everything is up to date up through last Saturday night. No, yes, I believe up through last Saturday night are all uploaded onto YouTube, at least the week before. It's something like that. So it's good to have all of you here. Feel free to make comments during our Bible study. And if you want to make comments on the recording later, that's good as good also. Neither my employer nor my church takes any responsibility for anything I say. And we are studying the age of the earth. How old is the earth? And trying to consider that question. And we started the scientific evidence last week. We talked about the theological perspective. We talked about the biblical arguments for a young earth. We did the chronogenealogies that kind of gives us the age of the earth biblically. And last week we started the scientific evidence, and we're going to continue that tonight. I don't know if we'll finish it tonight or not. I think we got through 4 last week, and I think I have like 10 more to go. So we'll see. Some of them are very short, so we'll get to those. Just real quickly, just so we know what our comparisons are. If you are an old earther, if you're following an evolutionary Big Bang perspective, the universe is about 13.8 billion years old. The Earth is about 4.5 billion years. Your fossils are in the 3 billion to 200,000 year range. Well, you have some newer ones as well. That's what you're looking at. If you're looking at things from a biblical perspective, the creation is about 6,000 years old. The fossils are about 4,500 years old. The stars and the planets and all of that are also 6,000 years old. So creation-wise, 6,000 for creation, 4,500 years for the fossils formed by the flood. Big Bang, almost 14 billion years. It's a huge difference. That's one of the important things. Okay, so let's look at some of the young Earth arguments. I think these are the best, or some of the best. We will deal with some of the strongest old Earth arguments later. Again, starlight and time and the Big Bang, and I will deal with that later. Okay, so let's talk about the James Webb Telescope. The James Webb Telescope, I'm not going to give you a lot of information about the telescope. It was put up in the last few years. It is an unbelievable telescope. It works very well in the infrared range, which turns out to be very good for going into what they call deep space. If you are familiar with astronomy, you are familiar with what's called the red shift. This is like the Doppler shift for sound. If a sound is coming towards you, it gets higher pitched. If it goes away from you, it gets lower pitched. Light also does that, except it doesn't have a pitch. It has a wavelength, a color. And so it's called a red shift because if it's moving away from you, it goes further towards the red range. If it's far enough away from you or going fast enough away from you, I should say, well, they're connected. It seems as though the farther away an object is, the faster it's going away from us. It goes into infrared. James Webb Telescope is very sensitive to infrared, which means that they have been able to go very deep into space. They have been able to find galaxies at what they call the Hubble numbers 11. Well, the Hubble telescope went out to Hubble 11. The James Webb Telescope is going out to 16 and 20. What that means is they are looking at galaxies, specifically galaxies, that are very, very, very far away, moving away from us very, very fast. And according to evolutionary perspective, naturalistic perspective, They are actually looking back in time. Because the light takes a certain period of time to get to us, the light that is getting to us left that star that time ago. So what you're seeing is not the galaxy today. You're seeing the galaxy when the light left the galaxy billions of years ago. And they are actually looking at galaxies that, from their perspective, are very, very early in cosmic history. They are looking at galaxies that are less than 250 million years after the Big Bang. Remember, the Big Bang is 3.8 billion years ago. So they are looking back in time more than 3 billion years to within 250 million years of the Big Bang. Now, here's the key. Galaxies should take 400 million years to come into existence. This was the theory. The theory was that after the Big Bang, in about 400 million years, they talk about such huge numbers, they're almost incomprehensible, but that's beside the point. 400 million years after the Big Bang is when galaxies start to form. What they're finding are galaxies that are less than 250 million years after the Big Bang. They believe they're looking back far enough in history to see galaxies that are only 250 million years from the Big Bang, and they are large galaxies, and they are what are considered mature galaxies. There shouldn't be any galaxies. According to the evolutionary theory that they had, the cosmic evolution theory, the Big Bang, there shouldn't be any galaxies. There certainly shouldn't be huge mature galaxies 250 million years after the Big Bang. They expected it to take at least 400 million years for them to start to form. Not just form, but start, I mean, like, not to get to full growth, but to start to form, at least as I understand it. These are messing things up. This was an interesting quote. I got this from ICR. He says, granted, these results are preliminary, but even these initial reports are causing angst among theorists. University College London, cosmologist, so cosmologist of the University College London, Richard Ellis, says, it worries me slightly that we find these monster galaxies in the first few images. University of California at Santa Cruz astronomer Garth Illingworth rhetorically asked, how do you do this in the universe at such an early time? How do you form so many stars so quickly? And this was the fun quote. University of Kansas in Lawrence astronomer Allison Kirkpatrick said, right now I find myself lying awake at 3 a.m. wondering if everything I've ever done is wrong. This was disrupting. Now, I am fairly confident that they have readjusted their numbers, and I believe one of the things they're doing is simply making the universe older than they originally thought. I think it went up to 15 or 16 billion years. And so now they're not as old. They're now, the universe is old enough now that these galaxies are far enough from the Big Bang to exist. They just changed the date. They can always change the theory to fit the evidence without giving up their basic presuppositions. They really can do that. The other problem that they're having is that these distant galaxies are bright. And the problem with that is that the understanding is that the universe has been spreading out for 13 billion years. And if it's been spreading out for that long, those galaxies should be stretched out and they should not be so bright. So that's another issue. That actually would affect some young Earth creationist theories as well, because there are young Earth creationists who have accepted the expansion of space, and that kind of a piece of evidence would actually cause them all issues as well. There's a lot of theories about the early universe 6,000 years ago, as well as 13 billion years ago. Okay, another one that is really cool. I'm going with some of the ones that are a little more in depth first, and then I'll be hitting some much more general ones. In the late 1990s, early 2000s, there's something called the RATE Project. I believe I mentioned this last week with diamonds. Several creationist organizations got together. They were specifically looking at radioactive decay. And when they were looking at this, one of the things they looked at that had some really significant results was helium in zircons. Now, in these zircons, There are radioactive materials that have gone through what we call decay, which may not be the best term, but it changes from an unstable element to a more stable element through a series of steps. Many of those steps release helium. So as it's releasing helium, you can look at the helium and measure how much helium being produced tells you how long it's been decaying, or gives you a way of estimating how long the material's been decaying. At modern decay rates, if the helium is produced by radioactive decay and the helium is still in the rock, you know that at least that much radioactive materials decayed, and you can, with you're looking at daughter products and mother products, you can get an idea of a time frame. Now, if you are a young Earth creationist, you only have 6,000 years to work with from creation. If the radioactive materials were formed in the rocks at creation, then you have 6,000 years. The reason this is relevant is the helium, much of the helium is still in the zircon. So that helium has been in that zircon for a certain period of time. It naturally travels out of the zircon into the surrounding rocks and then into the atmosphere. Therefore, you can, by looking at how much helium is there and how much decay apparently occurred, you can kind of get an idea of how fast the helium should be traveling. If it is like 600,000 years of decay, according to modern rates, it would be 600,000 years of decay, and the helium is still there, then it must be traveling very, very slowly through the zircon. If instead it's been 6,000 years and the helium has been migrating through the zircon for 6,000 years, it's still pretty slow because these are fairly small crystals, so it's still very slow, but 100,000 times faster than the evolutionary uniformitarian naturalist time frame. Now, how fast does helium go through zircon? Nobody knew. Nobody had ever measured it. It was an unknown. So therefore, it's a great chance to do scientific method. Creationists made a prediction. If these zircons are 6,000 years old, as the Bible says, the rate of helium through zircon would be this speed. If instead we are going with the old Earth perspective that these things are hundreds of thousands of years old, then the rate would be this. And I just realized that I have the wrong numbers. It was 1.5 billion was the number, was the age for, according to evolutionary assumptions. So the 1.5 billion years versus 6,000. And so they measured it. They measured how fast the helium travels through zircon. And it worked. And the prediction, they made a prediction based on 6,000 years. They made a prediction based on 1.5 billion years. When the data came back from the lab, it matched the young Earth creationist prediction beautifully. 100,000 times too fast for the evolutionary estimate. That's where I got the 100,000 from. My eyes slipped lines on my notes. So here's the deal. It was an unknown prediction based on young Earth creationism, prediction based on old Earth. Put the two together, check the data. Data supported the young Earth position. Now, what's really important about that is the amount of decay is, in fact, 1.5 billion years of decay at current rates. What does that mean? Well, it means that you got 1.5 billion years worth of decay in 6,000 years. And the theory that was being promoted by the rate group was accelerated radioactive decay. That in the past, either during the flood or simply in the past, that's a little unclear, that during that time, radioactive decay happened more rapidly than it does today. So all of the radiometric dating that we have is inaccurate because the rate in the past was faster than in the present. What's really neat about the RATE project was it didn't just say radiometric dating is unreliable. What it said was we need to change the formulas because the rate changed. And Dr. Chafin actually did some research that indicated what kinds of radiometric decay, alpha versus beta, accelerated more or less, and whether or not longer half-lives versus short half-lives, how much the rate changed. There's actually ways of predicting this. I don't think the rate project quite made it, but what the rate project did was to open the door to actually creating a better way of using radiometric decay for estimating the ages of things from a young Earth perspective. And the theory and the helium in zircon completely supported the idea of accelerated radiometric decay in the past. I hope that was clear. It's a little technical, I realize, but I hope I was able to communicate it clearly because it's really a neat thing. Again, you can check creation.com is where I got my detailed information about that, although it's also in the rate book if you are interested in reading Thousands Not Millions by edited by Don DeYoung and put out by the Rate Project. Okay, a little shorter ones, a little bit more highlights rather than so much depth. The salt in the ocean. When I first got into young Earth creationism, again after we went to Taiwan, I'd done some when I was in high school and then kind of left it during college. When we went to Taiwan, I got reinterested in the topic, and the moon dust argument was being discarded. And I contacted the creation organization in Australia, which Ken Ham was originally associated with before he left Australia, went to California to join ICR, and then on to Kentucky to found Answers in Genesis. The Australian organization, Andrew Snelling is also part of that organization and several others. I contacted them and said, okay, so what can you replace the moon dust argument with that's simple and clear? And they gave me the salt in the ocean evidence. So the ocean is getting saltier. We can measure this. We look at the amount of salt that goes into the ocean, the amount of salt that goes out of the ocean, and the ocean is getting saltier every year. There are flaws in what I'm about to say for many reasons, but it's okay because they're all their flaws. Let me say it this way. We're taking today's rates and extrapolating backwards. As creationists, we might say, well, that doesn't really work because those rates may have changed. That is correct. However, if you're a uniformitarian, you would say, no, the rates have always stayed the same. So we're actually using, good evening, Stephanie. We're actually using a uniformitarian argument. We should be getting a very old age for the Earth because we're using their assumptions. So if you do that, all you get is 62, it's like 45 million years. But then the evolutionists, well, yes, but there were some variations. And if you add their variations based on their theories, you get out to 62 million years. 62 million is a long ways from 4.5 billion. Okay, you are literally a hundredth of the history of the Earth. You need to explain how the oceans are not 100 times saltier than they are. Ballparking. Now, from a young Earth perspective, we don't have an issue because A, we can assume that the ocean started salty rather than fresh. That 62 million years assumes a fresh ocean when you begin. We don't have to assume that. We can assume that God created salt in the ocean. The flood would cause more salt to go into the ocean. It would accelerate the saltiness of the ocean. Both of those things means that 6,000 years is completely believable, but 4.5 billion is not. So the salt in the ocean says that there simply isn't enough salt in the oceans for a 4.5 billion year old Earth. You have the same issue with erosion. And there's two sides to this. Continents are eroding and being carried into the sea, into the ocean. At the rate that continents are eroding, they could not be 4.5 billion years old. No matter how tall they were, over 4.5 billion years, they would have eroded into the ocean. If you look at the sediment at the bottom of the ocean, which is where that eroded stuff goes, there's not enough sediment in the bottom of the ocean for 4.5 billion years of erosion. Now, there are counter arguments to this. They claim that there are factors that will put the sediments back onto the continents. So there is some counter argument to that, but it's another really good indicator that the Earth isn't 4.5 billion years old. This one may get a little bit more involved. That's the comets. I like this one though. Some of you are familiar with comets. Um, there are short-term comets and long-term comets. Short-term comets come every couple hundred years. Long-term comets take longer. Um, they have little different paths and etc. All comets have an elliptical orbit, so they come very close to the sun and then they go very far away from the sun and then they come back again. They are basically a dirty ball of ice. As that ball of ice gets closer and closer to the sun, it glows. As it gets close to the sun, the solar wind from the sun rips pieces off of the core of the comet, making the tail. So when you see the tail, that's pieces of the comet being ripped off of the comet and thrown away into space. So every time the comet comes past the Earth or past the sun, it gets smaller. If you have a short-term comet, it can only make so many loops around the sun before it's totally destroyed, and that limits its lifespan. As I was studying for this, I not only do you have that, which is what I've always heard traditionally, but you also have the possibility that a planet, some of these big planets with lots of gravity, like Jupiter, can attract a comet as it goes by and drag it into its gravity, and it will crash into the planet. Shoemaker-Levy 9 crashed into Jupiter a few years ago. And so you have that possibility. Also, when they go by some of these large planets, instead of the planet dragging them in, capturing it with their gravity, they can maybe just bump them enough that it bumps them out of their orbit and they will wander away from the solar system entirely. Adding all of that together, crashing into planets, being ejected by planets, and just being ripped to pieces by the solar wind, the maximum life for a short-term comet is 20,000 years. Now, according to the Bible, we're only 6,000 years old. We have 14,000 years of short-term comets yet left. Some are not. I mean, there's some that are going to disappear, so there will be fewer and fewer comets as we continue forward, but we still have about 14,000 years of short-term comets. If you are an evolutionist, we are 4 billion plus years since the last short-term comet disappeared. There are no short-term comets. Well, we know there are. Evolutionary, according uniformitarian wise, there is no way for comets to still be here. Short-term comets specifically. Long-term comets, because they take longer to go around, they are going to last much longer. And since they're long-term comets, we don't even know exactly how long. Like some of them are long enough we haven't seen them twice. Now, so what's your answer? Well, your answer, of course, is, well, there are new comets being produced all the time. Well, where are they coming from? Well, there was a theory called the Oort cloud. And this Oort cloud was suggested as a bunch of comet cores orbiting the sun. So they're going around the sun outside Pluto. They're orbiting the sun. And periodically something bumps one of them in some way, and it drops into orbit and becomes a new comet. Biggest problem with the Oort cloud is nobody's ever seen it. They don't expect to see it. They don't believe they can see it. It's purely theoretical. Also, they've actually given up on the idea that short-term comets could be caused by the Oort cloud. It has to be long-term comets could come from the Oort cloud, but not short-term. Doesn't really solve the problem. So now they're turning to the Kuiper belt, and I may be mispronouncing that word. It's Kuiper. For some reason, to me, that says Kuiper. The Kuiper belt. This is outside of Neptune, and this is where they're arguing now that short-term comets come from. Now, it's actually interesting. They're calling the technical name for these. They have found them are trans-Neptunian objects. TNO. One of the trans-Neptunian objects is Pluto, the former planet. Poor Pluto has been degraded from planet to a trans-Neptunian object, and there are other ones. There are other trans-Neptunian objects, which are chunks of stuff outside of Neptune's orbit that they are now saying maybe this is the Kuiper belt. Now, it may not be, but this is what they're suggesting. The biggest problem with this is that the composition of these objects, to the best of our ability to observe from this distance, is nothing like a comet. and most of them are way too big to be a comet. So um, that doesn't solve their problem. It's a response, but it hasn't solved their problem. There's always a response. There's argument back and forth, and it's always going to be that way. Okay. Uh, I only have 3 minutes, and I don't have time to do the last four. Um, Let me go ahead. Well, let me do this one. Polystrate fossils. I could spend more time on this, but I can do 3 minutes worth. There are a number of fossils. Most of them are trees. However, there's also a whale. And these are fossils that are very large or long that go through multiple layers or through layers that are formed very slowly. The whale fossil is a full whale buried in microscopic little sea creatures. So these little sea creatures take a long time to form a layer of rock around the whale. But the whale is in very good condition, not the flesh part, but the skeleton part is in very good condition. It could not have been on the ocean floor for more than a few months at most, and the skeleton be in that good a condition. But for those microscopic creatures to die and sink and form these rock layers would have taken hundreds of thousands of years or tens of thousands of years. The whale couldn't have stayed there. Much more common are polystrate trees. And so, especially in coal beds, you'll find trees that are vertical or slanted, not growing because their roots are gone. It's just the tree trunk suspended vertically through multiple coal layers. Each coal layer takes like 10,000 years to form. I don't remember the exact number. It takes long periods of time to form the coal layer, and then there's a layer in between that they think is when coal is not forming, and then there's another coal layer. And these trees go through multiple layers. But the trees are vertical, so they're standing upright through all of this burial, and they are unrotted during that thousands of years. That tree trunk is not rotted while it's sticking up through. And remember, they don't have roots, so they're not growing in the coal seams. Polystrate fossils are a strong indication that the rock layers formed rapidly rather than slowly. When we get to polystrate fossils, we're moving from the age of the Earth at 4.5 billion years old, or the age of the solar system, or the age of the universe at 13 billion, and we're moving more to the fossils and the rock layers, which we're still dealing with 3 billion years for the fossils and rock layers. I mean, the oldest ones. But this one is evidence. Polystrate fossils are an argument that the rock layers and the fossils were formed much more rapidly, and therefore are consistent with a young Earth rather than an old Earth. Okay, that is part 2 of scientific evidence. We will go on to part 3 of scientific evidence next week. Lord willing, please come back and join me then. Have a good Sunday tomorrow.